So welcome to another series of Ninja Hack. Today we'll be talking about Fileless attack and how to analyze malicious PowerShell script. So what exactly is a Fileless attack? This type of attack does not require malicious executable file to be written to disk. This form of attack majorly occur in the random access memory, and that is they exist within a system memory. So their aim is to, as much as possible, evade any form of detection on antivirus endpoint security solution within that system, right? This type of malware finds its way to its victim using trusted or standard window applications, like PowerShell, Microsoft Office applications. Let's just take a look at how this form of attack works. Could see how a fileless attack works. So let's just go through a scenario where a user receives a spam mail through an email, and the user clicked, on the link, the malicious link. What happens next is that the malicious link tries to connect to a remote location, or a remote network, which is commonly called a command and control server, right? So if that connection is successful, what happens next is that remote script execution takes place in memory. Don't forget, I said in memory. So it's most of the time, fileless-based attack does not aim to download a file and save them on the disk. What they do is that they try to execute scripts in the system memory. Like I said, to as much as possible evade any form of detection. And if that is successful, it's not stopped by advanced anti-malware solutions, like that uses machine learning and behavioral-based analysis. If you're just using a traditional antivirus solution, of course, you will not be able to detect this form of malware. And if that is successful, the malicious script tries to dump credentials like that. That is the user credentials, any form of credentials it can find on the system, majorly the authentication credentials, which is stored in memory. So the script collects data and sends those data to the remote server. So basically, this is a typical scenario of how a fileless attack work. And we have a lot these days of this kind of attack, right? So let's talk about the architecture, the mode of operation of fileless-based attack. As you can see, we have 3 stages. The first stage is the attack vector stage. That means there are different attack vectors through which fileless-based attack can affect a system or a network. Most of the time, it's always through phishing or spear phishing, where a malicious document is sent to a user, right? It could also be through malicious URL or a malicious site that has an exploit kit. So if you're most of the time, if you're running an older version of your browser and you're trying to visit some malicious site, what happens is that those exploit kits can do a scanning on your browser to see if there's any form of vulnerability that could be exploited, right? So that's the first stage, the attack vector stage. The next stage is the execution stage. So what happens is that one of the major goals for fileless-based attack is to establish persistency and also to establish lateral movements, within the network. So they do this most of the time by updating the registry keys. So the malicious script tries to update or, create a location within the registry, majorly to establish persistency and or to also use WMI objects, so if it's a VB script or a JavaScript, it's also tried to use WMI objects to, execute PowerShell. So most of the time, they try to invoke PowerShell scripts, maybe using cmd.exe, and the purpose is that most of the scripts are built using abused using PowerShell commands, and most of the time they're encoded, or sorry, of course they're encoded or encrypted using maybe base 64 encryption coding algorithm. So once that malicious script is able to establish persistency, maybe it could find its way to the auto start location within the registry keys. Then the next thing is to invoke PowerShell script. It could do that using CMD or directly to PowerShell script, sorry, PowerShell application. So once it invokes the PowerShell application, the next thing is that the PowerShell application will execute the encrypted script, So the purpose of that is, and it does that directly in memory. So it's most of the time the PowerShell script is not doing that on the disks because of course it's fileless. So we expect that it does not run on disks. Most of what it's trying to achieve is in the system memory, in the random access memory, right? So the malicious script is executed in memory, So what it does is that it tries to create, it tries to inject another process within the memory, so to dump credentials, or to do basically any form of attack based on the design of that script, So when we have the malicious payload, like as you can see, the malicious code executes within legitimate process, within the system, and it could be there as long as the system is active, uh, within that time frame. And that's why most of the time it tries to establish lateral movement. So after affecting a particular system, it dumps credentials, look how to escalate privileges, look out for open ports, SMB protocol, SMB protocols to see if it could affect other systems within that network, So and also to get maybe to the Active Directory, to get domain accounts, privilege accounts, So these are all sort of activities that fileless-based attack can do. And most importantly, it could also serve as a dropper for other malwares like ransomware, rootkits, Trojan, and the likes. So let's just go through, before we start our lab, let's go through a sample PowerShell script. So the purpose of this script basically is to launch and download a remote file. So to be able to analyze PowerShell scripts, you have to be familiar with certain PowerShell commands, and flags. So looking at these sample PowerShell scripts, what we have PowerShell.exe-nop-w hidden. So let's go through it. PowerShell.exe just specify that a standard PowerShell command is going to be executed, right? So -nop means no profile. So PowerShell profile, basically what it does is it runs anytime PowerShell is started, on the system. So whenever you start PowerShell, the PowerShell profile also starts automatically. What it's used is it is used to customize the PowerShell environment. It's also used to load variables and certain functions, right? So, like I said, one of the major aim for fileless-based attack is to evade any form of detection, to go on in a stealthy mode, right? So no profile, what no profile does is that it's saying that do not start the profile, right? Or the profile should be started in invisible mode so that users don't get to notice what is happening in the background of this event, right? So we go on to see -w hidden. So W means Windows style. So it could be set to normal, minimum, maximum, or hidden. So most of the time, malicious PowerShell script goes with -w hidden, so to ensure that you hide the session of window from users. Users will not be able to see that a PowerShell window session is on. Then next is dash C, as you can see, which means that the next command that is following it should be executed. That's what dash C implies. It means command that the next string that is written after dash C should be run or executed, right? So we have IEX, which means invoke expression. So what this does is to run a specific string, as a command, and also return the results of the expression. So most of the time, it's always used on most of the malicious PowerShell script that I've also seen. We have another command, new objects. So what it does is to create an instance of a .NET framework. We have net.web clients, provide a common method for sending and receiving data, most of the time by using a URL, as you can see from the script. So we have the new, that's object. So these are PowerShell commands that you need to be familiar with to understand what the script is trying to do. As you can see, we have download string. So this try to download a file from a remote location. Look at the this is the URL, the URL that is hosting the malicious file, right? So it's basically this kind of events just try to run without without getting detected, right? And like I said, it's fileless, so it does not run on the disks, right? So one important flag to also note is -E, which means encode. So what this does is to encode the string, most of the time using base64 code encoding format. So what this command implies that PowerShell needs to decode the string if the malicious PowerShell script is encoded, right? So it implies that PowerShell needs to decode the script before running it, right? So this is what this has some of the major commands that we need to understand before going into our lab. So let's go on to our lab, right? See, so this is a lab from Blue Team lab. It's a free lab that's that will be going through more like a challenge to analyze certain PowerShell scripts. So we'll be going through the scenarios that we have right here. You can see. Let's go through this scenario. So recently, the network of a large company named Gotham Legend were compromised after after an employee opened a phishing email containing malware. So we have an employee here that opens a phishing email containing malware. The damage caused was critical and resulted in business-wide disruption. You see, so you can see that just from an employee opening a phishing email, it has established lateral movement. It has affecting other systems within the network, right? So you can see that the company had to reach out to a third party incident response team to assist with investigation. So right now we on the call here are a member of the incident response team, and all you have is an encoded PowerShell script, right? Can you decode it and identify what malware is responsible for this attack? So this is a very I think it depicts a real life scenario, because this is most of the time the kind of request you get as a cybersecurity analyst, to analyze certain scripts and help detect tactics, techniques, and procedure, of what is happening. So this is the PowerShell script. You can click here to download it. You can see I've already downloaded it. This is the password to open the file. So I'll just try. I think I've opened the file in the text. So because of time. So this is the file. This is the file that is containing the PowerShell script. We could also see that we have PowerShell, we have dash, we have the Windows tag, which is hidden. We have the dash encode. So this means that the script is encoded using this, most of the time using base 64. Most of the malicious PowerShell scripts are encoded using base 64. So all you need to do is to copy the script, the encoded script alone. Don't copy the PowerShell and all the flags that we have, just only the script. So right now we are going to use a web analyzing tool that is called Shelf. So all you need to do is just go and click for Shelf. So it's a web analyzer that can be used to, for encryption, decoding, compression, and for data analysis, right? So it's very useful. It's a very useful tool. So that's what we'll be using to analyze the script. So we're going to paste the script right here, right now. So I'm going to be speaking from experience that I'm like 90% sure that this encrypted script is done using base 64. But well, for the purpose of this demo, what we'll be looking at is let's see how we came out of that, come with that notion, that hypothesis. So this is how CyberChef works. So like I said, it is used to encrypt, to decrypt and analyze script. So it has several function operation, as you can see, that we can use. So I'm using an operation called magic. So what magic does is to help check and detect the various property of the encrypted scripts that we just pasted, and suggest which operation could help, make more sense with it. So from just going to run this. So we're going to run this to see if we can make sense of this script. So, but based on, like I said, based on experience, most of the time you will see that most of the scripts are encoded using base 64 encoding formats, right? So if you what I would just do, if I'm the one that is running this on a live environment, or or on a real life scenario, what I'll just is to pick this operation call from base 64. So it will just help me convert. But I'd like to show you guys why I have a strongest base 64. So that's why you can use magic to help you detect the scripts, go through the script and see if it can make sense of it. So we're just waiting to see what will come out of this. Okay, so you can see we have our results based on the analysis done using the magic operation. So there are two things you are trying to check. You're trying to see which of these result snipnets make sense for us, and also which of them has a higher entropy, right? So that will help us determine which of the operation we can use. Most of the times likely base 64, what I want you guys to see. So you can see this is Chinese, this does not really make sense. So we are looking out for something that makes sense, maybe in English, that we could see. If let's just scroll down a little. So okay, so guys, trying to scroll down. Let's take a look at. So this does not make sense. You can see the entropy is kind of low. Okay, so I'm seeing that we have, okay. So I can see something that looks like system. You can see type, right? Okay, let me see, but this is Russian. Okay, so I'm looking for something that will suit us. Is Russian. Okay, so let me just scroll down a little. See, okay, so this looks something like what we can use. You can see have a high, as you can see high entropy suggests encrypted or compressed data. So normal text is usually around 3.5 to 5. So you can see normal text. This help us to see this. This looks like normal text, right? So you can see type, you can see system. I think so. Like you can see every one of them, even down to I think most of them is from basis 4. So most of the time, just to save us a lot of time, we'll just go on instead of using magic to detect if it's base 64. I'll just go on to just use base 64 direct. We can see that our encoding format is base 64 here, and also the code text is also unified transformation format is 16LE 1200. We can also see that here. So let's go on with this suggestion. So what we're going to do is to remove our magic, then we'll bring in our basis for encryption encoded format. So you can see that our script has encrypted script has been decoded, but we still need to make a lot of changes to make sense of the script. So you can see this is showing us this is the decoded format of the script. Want us to bring it out and see. Let's create a file. You see, but there's still a lot on the script that like we can do. So I just want you guys to see what the script look like. There are certain we can see that we have. You can see variable, you can see type, right? But currently we don't know what the script is doing, what the script is trying to achieve. So that's why we need to work on the script. You can see download, so let's go back to, so right now, don't forget, we also saw from the magic, we saw decode, trying to decode text. So we are going to take decode text operation, right? So we have the various decode text formats. So what we saw during the magic results was UTF 16LE. So you can see this help us to make more sense of our script. You can see, so I'm going to copy this out again to Notepad. So let me remove these. So we have this. So this seems to be in a more readable format. You can see variable, right? You can see crates, looks like create directory. So, one thing about PowerShell script is that what these attackers try to do is that they try to make it unreadable as much as possible, so that it's like by encoding it, by writing it in an unclear text. So you can see we have some clear like download. We can still make sense of some text, but right now we don't even know what this script is trying to achieve. So and don't forget we have a challenge to go through. So let's go through. The first we are being asked of here is what security protocol is being used for communication, right, with a malicious domain. What security protocol is being used for communication with a malicious domain? So let's go check on our scripts. So this also will help us, as cybersecurity analysts, what exactly are we looking for on a PowerShell script? We are looking for security protocols. We are trying to look for malicious URLs. So from I think before we go on, we could I would like you to notice that we have semicolons. We have several semicolons. Most of the time in programming, in shell scripting, when you have semicolon, it indicates the end of a statement, so I would like us to see if we can, try and, kind of break down each statement. So this just indicates that this is a single statement so that we could try to make it more readable. So we can also do that from the side chef, to replace the semicolon with maybe a new line. So it will just break it automatically for us. So I'll go back to, okay. I'll go back to and look for an operation called, I think it's called find and place. Okay, so let's remove any form of semicolon. What we'll do is remove any form of semicolon and replace it, with replace it with a new line. So replacing it with a new line, which is slash, yes, is slash n. So also come here to do this, then run this. Yeah, I think, oh, okay. Oh, sorry. So we can see that our semicolon is no more, is replaced with a new line that's broke down the what's it called, the scripts into individual statements so that we can easily read it. So right now, okay, sorry, okay. So right now, I'll just try to paste this down here, guys. You can see. So instead of this manually, we've been able to do it via the side chef. Okay, so guys, the first question is that the challenge is in what security protocol is being used for communication with the malicious domain. From this, from the scripts, we can see, let's try and look out for any security protocol case. So we have a security protocol. We can see that it is tending towards TLS, I think version 1.2. That's so we also need to understand the structure of scripting. We can see that we have plus sign most of the time. What this means is concatenation, So to also confirm, we can take this to PowerShell. I like to spin up PowerShell. Let me spin up PowerShell, right? And let's try and confirm. Try and open PowerShell, guys. Okay, so we have our PowerShell. Let me copy, do an echo. I think I didn't copy the string, so I'm going to copy these from the column, copy it out, right? Then you can see security protocols equals TLS 1.2, which basically means TLS 1.2. So let's go on to format and do TLS 1.2, right? So CO, do we need to think, let me see, okay, format TLS, let's see, okay, wow, okay, so I think it's the format, so you can see we're correct, this is TLS 1.2. So let's go to the next question. What directory does the obfuscated PowerShell create? Starting from home. So, this will help us. Like I said, as security analysts, we're trying to understand the tactics, techniques, and procedure of the PowerShell script, right? So the next question here is, what directory, since we now have understanding of what protocol is trying to use to communicate with the malicious domain. So now, what directory, if this is actually successful, so the next thing that is tries to create a directory, right? So what directory is it trying to create? So let's look at our script. Okay, so earlier on I saw create directory. So, and if you look at the question, saying that starting from home, right? So what we're going to do, this seems to be like the directory, but how can we know what this directory mean? Like I said earlier, this is home. This, of course, means this, right? So, but we also need to find out what exactly. So this is concatenation. So home is concatenated with, several other strings here. So like I said, what I like to do most of the time is to take the script and try to run them through on PowerShell. So I'm just going to copy this out and see what exactly it's gonna. Wow. Okay, so let me see. Okay, so sorry. I think I missed something. Okay, let me copy that again and close this session. Okay, so echo, and I'm going to do is, why isn't it copying? So I want to see if this actually will result into a directory. Okay, looks similar. So we can see that this, so as you can see, the home here actually represents the home. We are already given a hint here. So all we need to do is to replace our parts, our current parts on the system with the home there. So if we even try to echo only these, right, you could see that the result will give us something similar. Okay. So have, okay. I think I need to remove a bracket. I think I need to remove closing 1, 2, 1, 2. Okay. You already have brackets. Okay, let me look that up again. I want to see if I can do an echo for this only. I think it should be possible to do that. Okay, so just going to do this. I think it's saying that. Okay, let me look at what about for this string. So we have these. Okay, so I think there are three. We have three closing braces and we have just two. So of course, something wrong here. So I can, this should work. Okay, yeah. So I think it was a brace, closing brace that's causing the issue. So we can see that actually this seems to be like a directory path after removing all the form of plus concatenated signs that we have here. You can see that this is the directory. So what we need to just do is to copy this out, right, and have and put that in the file. And don't forget from the hint, it has given us that the should start from this, from home. So I think we should have something close to this, right? So because as you can see, home is already here. This is our home. It's concatenated. That means it's joined. and we're able to decode from PowerShell that this is the same thing as, right, this, right? So let's see if it's successful, correct. Yeah, it seems to be correct too, right? So the next we are going to look at is what file is being downloaded. Okay, so let's take a look at the script once more. Let's try and understand. So we saw create directory, right? Also, I can see that we have some sort of variable name here, and we have the variable value. So like 3 variable and their values, right? So right now we have 3 variables and their value. Let's see if there's any reference to any of these variable in the script. You can see that it's also referenced here, and we can see it's .dll. If we remove this concatenation plus sign, and have .dll as the extension, right? So I think so out of the 3 variable, only one of them is referenced, right? So look at this code. So we have a variable value, then also we have a variable name, sorry, then we have the value. We have home, right? It's also concatenated with all these. So, like I will always do, I will try and copy the string out, especially this, and try to see if I can make sense of each from my from the PowerShell. So I'll just try and do declare. Yeah. So let me try. Oh no. Let me. Okay. So we can see I didn't even use my echo. So let me just put that. So you can see that echo running the script on PowerShell is resulting into this result. So you can copy this out. You can see this is what we got. We have these. So this means this long string is the same, right? As you can see, we have this is the first before we have a concatenation sign. So this is the same thing as this directory, right? Wow. If we take a deep analysis of these two, we could also see that this kind of the string is kind of the same as what we have over here, because how did I know? If you look at it, you can see that we are replacing u plus oh, that is uoh. If you remove the concatenation sign, you can see that we have uoh here. If you remove everywhere you have uoh, right, you have uoh, the remaining string will be the same thing as this, right? So using PowerShell is way quicker. It's help us to, decode that this is what the string is, right? So then we have a plus concatenation sign. Then this is what we have next. Then we have a plus. So PowerShell could not find what this variable name actually means. So, but look at this variable name is also referenced. And if you look at what the variable value it contains is this, right? You can see it from the script. So let's take a look at this also on a PowerShell. Is there a way to run this? You could see it means A69X, right? So we'll take these values and try. So if let's do this, right? So we can replace this value wherever we have the variable name, right? So this is what we have. So if we go back to try and decode these, okay, so try and decode these, we can have Um, guys, the next thing we are going to do is to, since we've replaced the variable name that we have here, going to try and see this also give us, yeah, echo. So let's do an echo for these. So now we have two, two, okay. So like to enclose all the string. So this two, two. Okay, so we have more closing brace. So I'm just going to put one of them. Yeah, so if we do, okay, so we can see that we have A69X then plus dot TLL, which is the extension. So if we want it to, could just introduce an open and a closing brace over here. So let's see just this. So we now have this value, this this name kind of look reasonable. Like we have these dots DLL, so it's a DLL file, right? So from this, what it basically means that since we have our home, right, then we have the concatenation sign, then we are able to decode that this string here is the same thing as the directory part where that we detected earlier. Then also we're able to deduce that the variable name that was referenced here um, is this. We replaced with the value of the variable name. So we are also able to deduce from PowerShell scripts, from PowerShell application, that it's a DLL file, of course, and this is the name. So let's try and see if that makes it true to the answer. Sure. Yeah, great. So you can see, guys, it's kind of make it true to the answer. So this is the name of the file that was downloaded, right? So it's a DLL file that was actually downloaded using. So I don't know if you guys actually understand what we're doing. So let's go through the script once more. So this is, don't forget, we have the PowerShell. Uh, see this script. So we have the PowerShell, we have the dash W, yeah, hidden, which hides the window session. Then we have the encoded dash encode, right, which actually encode the script using B64 encoding format. Now from that, we're able to use the cyber chef to deduce the script into a more readable format, which we have here. And from what we've seen so far, we've seen that the script, first thing was that it tries to use TLS 1.2 version 1.2 to communicate with the malicious domain. It tries to also create a directory in the home directory part, and we also able to deduce the part of that directory, right? So also next thing we're able to also deduce the name of the file, you know, looking at the fact that we have variable names and value, and also of course, if since we have the name, uh, the name of the directory, so what we follow after is of course the name of the file, and we of course, we also know that .dll is a legitimate extension, of a file. So of course, that kind of gives us a hint to what the full name of the file is going to be, be like. So the next question would be, without wasting much time, what is used to execute the downloaded file? So if we go back to the script to see exactly what we know the file, so what else can we find here? We can see that we have another variable name, right, that contains kind of, do we have any semicolon? So this is where the script ends. So we have a variable name that contains this O value, right? We also have, you can see a for each loop on the script. So what it's saying that this we be looping through another variable name. So we have another variable name that will be going through these. So what I can see here is that we have a variable name that contains a value, right? That will be going through this um, this this variable name that's already referenced here that contains so much list of value. So I think the next thing we need to do is to find out exactly what these values are, and just like we did the other time, we can still use our echo to just try and see what exactly are those values. We can drop them echo PowerShell application. I don't know, I copy. Okay, so um okay, so this seems to be like some sort of URLs, of course. So most of the time we expect that PowerShell script to contain URLs domain, so either the URL through which they will download the malicious um, um, files from, understand, and also that the URLs you try to to reach, especially on the CNC server. So from what we can see here, we have certain malicious domains URLs. Sorry, let's see, HTTPS. Seems like we have a list of URLs here that are kind of separated with an art. Alright, so let me just copy this out to the Notepad++ to make to see some sort of sense with it. Okay, let's go down. So okay, you can see list of URLs. Wow, trying to need to close that out. Okay, so kind of, so what this means is that we um what it means is our script, the malicious PowerShell script, actually contains certain list of URLs. Some are HTTP, some are HTTPS. You can see, but kind of they are separated with an at. So what we could do from here is to say, okay, since we know that we have a for each loop that this variable is trying to iterate each through each of the URLs here, right? So you can also see that we have the new objects and system system uh, .NET.web clients, and we've talked about what they do from our slide. We said they provide common method for sending and receiving data, right? Using identifier from a resource identified by a URL. So this is this command, PowerShell command, is basically used to ensure that you can download and send data, via certain URLs. that we've detected. So, and we have a download file, please, and we have a download file over here. So this is what we can do. Okay, so let's take a look at what the statements also mean. So after the for each statement, where this variable name had to look through the list of URL, then we have an if statement here that shows get item, and we have dot length. So this kind of check, uh, based on my assumption, does like a check um, if the statement is valid, right? The for each statement is valid, and you can see run DLL file, run DLL 32. And of course we know that run DLL 32, what it does is to um, it's used to run DLL dynamic link library applications. And at the top of my head, I, I can I'll be suggesting that since our malicious file is a .dll, um, is a DLL file that has a .dll extension. Of course, the program that will be used to run that is run DLL, of course, because that's what it does. That's the function of run DLL. But I'm just trying to make sure that uh, those suggestions are backed with fact. So we can see the run DLL application here. Okay. From what we can gather so far from here, if we try to check through Powershell, what we have is control run DLL. So my guess is basically going to the run DLL 32 application. That is what the question is, basically what is used to execute the downloaded file. So most times, as we know, .esc application tries to call DLL files, because you can of course run DLL files directly. So that's why we have run DLL 32.esc, which is basically used to run and manage DLL applications, which is dynamic link library files. So what I'll just let me drop my guess. I feel that based on what I've seen so far, right, kind of going to be DLL 32.esc, because that seems to be the only applications that we have here. Let's see. Okay, kind of I'm not getting the format correctly. Run DLL 32. Okay, two, just like what we saw. Okay, fine. I think .esc is not stated in the script, of course. Okay, so what is the domain name of the URL ending with this? Okay, so don't forget, guys, we be able to deduce some URLs, using the echo previous times. Let's see. Okay, so you can see, guys, I think this is the only one that is ending with. We have other URL files. So this kind of seems to be the only one that's ending with the ending with 6F2GD, right? So that is it. I guess this is our answer. So this is what is the domain. Yes, this is it. Let's see. Okay. Let's see, this should be it. this is the domain name, right? So okay. So guys, hope you are clear. Hope you understand how we got this, because you can see this is the only domain that has this part and it, right? As you can see, that's why we have this as our answer. So the last part is based on the analysis of the obfuscated code. What is the name of this malware? So this way we need to do some search. Try and what exactly are we searching for? Basically, doing search for using so I expect that we can do search using either the malicious file name or the directory path. Let's see, check trigger group. So I want to do something like this. Let's copy this and do search generally. Right. So I'm going to just open Google and do this. If there's anything that's coming out, okay, so you can see that you can see out there. You can also see from here that this kind of seems familiar to what we have of what we discovered. So don't forget, the question is around exactly based on your analysis of the obfuscated code, what is the name of the malware? So we are looking out to see what could be the name of the malware. So to get that, we could try and open some of this sandboxing. Okay, so we have any, this is my favorite sandboxing application. So I'm going to open that. Okay, so we have malware analysis report here. So this could kind of give us some better overview before we have. Okay, so from any dot run, we could see that it's been identified as emotet, right? Let's see. Okay, let's go through. See. Okay, so this kind of seems to be like based on what has been detected in the wild. This kind of seems to be like the behavior of the uh, malicious PowerShell script, where it's spun up kind of, let's say we have a malicious document or attachment that tries to invoke PowerShell.exe, and of course you can see um, PowerShell.exe executes the malicious script, using rundll 32.exe, right? So it's kind of being identified as what's it called, um, emotet. So um, what other lessons can we draw out from this, right? We can see that apart from analyzing it, we can also see that we can gather information around malicious URL domain that could be blacklisted on the perimeter firewall. We can see the list of IOCs there. We can see malicious IP addresses. That's the applications such as PowerShell.exe, run.dll.exe are trying to connect to. So we can see the reputation of the IPs. 3 out of I think this is 5 of them are malicious. So we expect that we can gather reports of these and uh, send to our team, that are responsible for um, managing firewalls to block some of these malicious IPs. So basically, apart from analyzing the script, we can also um, deduce IOCs, based on our analysis. You can see malicious domain, just like the ones we got. So we expect that these are blocked on the perimeter firewall, these IP addresses too. So basically, this is a very good analysis. But let's see. I hope this is what's noted. This should be what it is identified as. So let's have these. Oh, great guys. So I think that is it. We are done. Yeah. So one other thing I would like to, okay, Like I said, we need to gather enough IOCs so that we can mitigate against such threat, you know. So we could do that by going through several sandboxing environment reports that have a lot of information about this threat. Because see, this kind of explain to us, um, this is a sandboxing environment, so that kind of explain to us how the threat was conducted, so we could better understand the tactics, the techniques, and the procedure. You can see from here, it tries to access several malicious domain, you know, try to spawn up cmd.exe, which also try to invoke partial.exe, you know, and look at the malicious domain that is tried to doctor. We got these URLs on our links, so you can see these are the same set of URLs. So this list of IOC needs to be submitted to our security teams that will make sure that they are blacklisted, you know. So thank you guys for going through this session with me. Yeah, watch out for my next series. Thank you. Bye.